First, a disclaimer. This exercise is linked with the previous exercise in which we configured loopback interfaces. If you skipped that exercise, you won't be able to configure the virtual link, which is what I'm going to do here. All right, we already mentioned that the recommended OSPF setup is to have each area directly connect to the backbone area, area 0. But sometimes it's not possible to have a direct link between area 0 and other remote areas, but you can virtually connect the remote area to area 0 by establishing a virtual link. Let's look at an example. Here we have 4 areas, out of which one is area 0. 2 areas are directly connected to area 0, but area 3 is not directly connected to area 0. What we'll do here is we'll configure a virtual link between routers A and D, which are area border routers. Also important to mention, area 2 will now be called a transit area. And this is our configuration right here. On router A, we will say area 2 virtual link, and then we say what is the neighbor with whom we want to establish the virtual link. The neighbor IP is recommended to be that neighbor's loopback IP address. And then we do the same on router D. We say area 2, which is the transit area, and then virtual link. So establish virtual link over the transit area with this neighbor right here. Let's get into our exercise. Let's check if our loopback IPs are still on the routers. We can see loopback 0 right here, loopback 0 right here, and the most important one is actually router web. And here we can see this 3333 IP address, because we will be establishing a virtual link between router LAN and router web. What we want to do first here is we want to configure OSPF. So we want to configure the basic OSPF stuff. So let's start with that. Router LAN enable configure terminal, and then we're going to start the OSPF process and advertise the networks directly connected to this router. Those are networks 192.168.0.0 and then /24 in a wildcard mask. That's 0.0.0.255, and then that network is in area 0. So we're going to say area 0 right here. And then on the other side we have network 11. So network 11 0.0.0, and that's 0.0.0.3 because we have the /30 mask, and that network is in area 1. Here it is, area 1. Network 11.0.0.0 belongs to that area, so that's that for router LAN. Let's go to router 1. Enable configure terminal, router OSPF 1, advertise all the directly connected networks, network 11.0.0.0.0.0.3, area 1. We can wait for that message to pop up and then continue. There it is. Let's advertise the other 2 networks, network 12.0.0.0.0.0.0.3, area 1. And then I'm going to repeat the previous command and enter 13.0.0.0 and then move on to router 2. On router 2, enable configure terminal, router OSPF network. We got networks 40.0.0.0, /24, and the same for network 50. And then let's advertise 12.0.0.0.0.0.0.3 area 1. And then we want to advertise network 14. We should get the neighborship established message with neighbor 2222. You can see that this time router ID is the loopback IP address, which is much nicer than some random IP address that you have to go back into your topology and look what that router is. So quite convenient. Let's go to router web now. This is an area border router, so we will have 2 networks in area 1 and 1 network in area 2. Let's start the OSPF process, advertise 13.0.0.0.0.0.0.3, that's in area 1, and then 14, okay. We didn't get there in time, so 14, we should also get that informational message for that network. There it is. Let's advertise network 15 now. So it's network 15, 0.0.0.0.0.0, this one's /24, so 255. And that network is in area 2. And then we should go to router data and advertise the 2 remaining networks. So enable configure terminal router OSPF 1 network 15.0.0.0.0.0.255 area 2. Let's wait for the neighborship informational message and then move on with advertising this network. That's interesting. Let's fast forward. There it is. That took very long. Okay, let's advertise 192.168.100.0.0.0.255 area 2. Okay, now what we want to check is we want to do a do show IP route command to see which networks we can see in here. So we can only see the directly connected networks. Let's check what's going on router web. This is an area border router, so it should be able to see the networks in both areas. Do show IP route. That's right, we can see first of all the loopback IP and then the networks that we learned about from OSPF in area 1, and then we can see this network which is in area 2, but we can also see this network. This is the intra area label right here, and we can see this network because logically this router web belongs to an area which is directly connected to area 0. But this router over here, router data, doesn't belong to an OSPF area which is directly connected to the backbone area, so it doesn't have all the information. All right, that hasn't changed, so we're not learning anything new here. In order for us to be able to connect all of these areas together, we'll have to create that virtual link. So let's get to that. I'm going to open router LAN command line interface, and we are still in router OSPF mode, so config router mode. What we need to do here is we need to list the transit area, and transit area is area 1 in this case. And then we want to say virtual link, and then we want to name the loopback IP address of our neighboring router with which we are establishing this virtual link. We want to establish the link with the area border router web, and router web's IP address, or rather loopback IP address, is 3333, so that's what we'll use. We need to do the same thing on a router web. See, we get this error message, received invalid packet, because this router LAN is trying to establish the virtual link, but router web is not configured to have a virtual link. So let's create it, area 1 virtual link. The neighbor with which we want to establish the link is 1111. And now we should actually get an informational message saying that this link has been established successfully. There it is. Now what we want to do is we want to go back to the router data and issue this do show IP route command. And this time we can see all the routes in this network topology. So we can see, first of all, the loopback IP of this router, and then 11, 12, 13, 14, 15, 40, and 50, and then 192.168 is 0. That's this network over here, and then 192.168.100 0, that's this directly connected network over here. By the way, speaking of loopback IPs, you can advertise this router's loopback IP. So for example, if we're in this configuration mode, we can say network 5555 and then 0000 and actually advertise this network. And if we advertised loopback IPs on each of these routers in our topology, they could actually see each other by their loopback IP addresses. And you would be able to ping router LAN, for example. You could say ping 1111. So you can do that, but there's not much point in doing it in this exercise. So I encourage you to try it out just for fun. Let's, just in case, test the connectivity to make sure we haven't missed something. That one works. Let's see if this one works, for example. It works. Okay, so that concludes this exercise. I hope it was clear for you. See you in the next one.